guys, this is My Star Dream, and our project aims to build an application which takes a user selfie here. A user selfie as input, outputs the most similar celebrity photo, and create all this like morphed image between those two, and then generate a video as an output. So our project mainly consists of two parts. First, it's the face recognition part. And as a model which is able to identify or verify a person from a digital image, face recognition works in a way to compare selected facial features from the input image with all the images within a dataset. And in our project, we use Celeb A dataset here, which contains around like 200,000 unique images by researchers at Lab, the Chinese University of Hong Kong. We also incorporate face alignment technique to improve our model's performance. The second task of our project is face morphing, which uses point-to-point correspondence in triangulation to produce several transition images between the input image and the celebrity image. And then the model will transform the transition images into a video. Now I'm going to show you how to run the whole application. First, you have a input image as in image directory named scarlet.jpg, as you can see here. And then you can run the face recognition model and then it's going to show you the output image after alignment. And this is the celebrity image which the models found the most similar. Then you go to face morphing model and run face morphing. And it's going to use the resize image from part 1 and then generate all the morphed image here. As you can see, 100 images. And we also have a video, output video here. And you can open the output video to see the transitions between your input selfie image with the output celebrity image. And that's it for the introduction.
For our face recognition model, we built a Siamese network and use Celeb A as our dataset and use triplet loss function to train our network. The steps is like this. At first, we put the anchor image, positive image, and negative image to the ResNet to get the embeddings of each of the image. The anchor image and the positive image are the images of the same person, and the negative image is a different person. And by using the triplet loss function, we try to maximize the difference between the dissimilarity of the same person and the dissimilarity of different person. And we add a margin here to prevent that the network trying to trivially satisfy this equation by just putting 0 for all the dissimilarities. After we train our network, we find that the model can output a very good look-alike for the image that's in the Celeb A dataset. However, for an image that's not in the Celeb A dataset, the output alike is not very similar. And we found that it's because the face images that we are using does not align with the images in the dataset. So we use face alignment techniques to make sure that the input images are rotated and scaled such that the position of the faces are approximately identical in each image. And then the results make much more sense after image alignment. We can see that the outputs alike are very similar to the input image after alignment. And this is another example. Before alignment, we can see that they are not very similar, and after alignment, it's very, very similar, the same person.
After we obtain the output image from face recognition step, we will apply the face morphing technique to show the process of how your face transformed to the celebrity looking like you. In this part, we firstly resize and crop the input image to make sure that the original and target faces are in similar position based on the landmarks of their eyes. After that, we use the method of point-to-point correspondence and triangulation to realize face morphing. There are 3 steps in this algorithm. Firstly, we marked some key feature points of both the two images. And here we use the face landmark detection by dlib to mark the 68 features of faces. Secondly, we used the line triangulation to divide the image into different sections. This step is to use the points we marked before to build triangles and ensure that there is no point lying inside the circumcircle of any triangle. Finally, we transformed each triangle in the original image to the corresponding one using the transformation matrix calculated by the 3 vertices of the triangle, and therefore we can transform the whole image. Here's the result video of the morphing process. And without image resizing and cropping, the result is like this. We can see that the morphing process is not as fluent as before.